This video is for the first set of notes for quadratic transformations. We're doing shifts today, but the first page that you have is this little cheat sheet. So we can tell the type of transformation it's going to be by looking at the function in vertex form. And so everything's labeled out for you here in vertex form. This is the A value, this is the B value, this is the C value, this is the D value. And that's how we label them in vertex form, even though we know this is the H, this is the K, these are the vertex points. So in vertex form, if there's a number here for A, if it's just a 1, so there's no value there, there's no vertical stretch or compression. When we stretch something, we pull it this way or we push it down together. Now, if the absolute value of A, meaning just take the number, don't look at the sign, is greater than 1, it's going to stretch that parabola vertically, okay? If that value is in between 0 and 1, it's going to compress that parabola vertically. And then if A is less than 0, so if it is a negative number, it's going to reflect it across the x-axis. So those are vertical stretches and compressions. If we have a number here inside the parentheses in front of x, that's a horizontal stretch. So horizontally, it's going to stretch it this way, or it's going to compress it this way. And it compresses it or stretches it away from that y-axis. So it doesn't just make the parabola skinnier, it actually pushes it towards that y-axis. So if B equals 1, so there's no value there in front of the x, there's no horizontal stretch or compression. If B is in between 0 and 1, again, absolute value, not looking at the sign, that's a horizontal stretch. So it's going to take that parabola and it's going to stretch it away from that y-axis. And then if B is greater than 1, that's a horizontal compression, so it's going to push that parabola closer to the y-axis. So horizontal scaling can shift the vertex. So this is one that'll change the vertex, but we don't deal with those a lot in algebra. So what we're doing today, we're messing with the C and the D values. So if C equals 0, if there's no value here, we're not shifting that function left or right at all. If C is greater than 0, we're shifting it to the right. If C is less than 0, we're shifting it to the left. So we're just pushing the whole thing over. It's staying the same thickness, the same width. We're just scooting it. And so the same with D. If we change the K value of the vertex, then if D equals 0, there's no vertical translation, so that's going up and down. If D is greater than 0, we're shifting it up, and if D is less than 0, we're shifting it down. So this is a good page to keep for these last lessons of this unit to help you with these transformations. So what we're doing today, we are doing horizontal shifts and vertical shifts. So a horizontal shift, we're subtracting something from the x. Okay? Vertical shift, we're adding or subtracting something from the end of the function. So again, this is messing with the y value of the vertex. This is messing with the x value of the vertex. All right, so f of x minus c, and it could be addition as well, and I'm sorry that it didn't print very well here, but this shifts the graph of the parent function left or right. And when we say parent function, that's the function that we start with. And with parabolas, that parent function is x squared. That's your most basic parabola that you can have. All right, so if the c value equals 0, there is no horizontal shift. If c is less than 0, it shifts the graph left. And if c is greater than 0, it shifts the graph right. This affects the x-intercepts of the parent function. So it's going to change where this parabola crosses the x-axis. So our parent function here is this one that's centered up nice and pretty for us. And that parent function again is f of x equals x squared. So the transformation here, I took this function, if I look at the vertex, I shifted it to the left 5 places. So my transformation would be g of x equals, so this goes inside the parentheses, and if I'm going left, I'm adding, and then that's still squared. So remember, when we're writing things in vertex form, if it says minus c, that's a positive number, okay? That's, or a, the x value of the vertex is a positive number. So you just kind of have to shift your brain with the way it's thinking. So the c value here is a -5, okay? So again, there's that shift. If I'm adding something to the x, I'm really working with a negative number, because if you subtract a negative, it changes it to addition. So this is a left shift. And then the same here, my parent function is this one that's lined up nice and pretty in the center, and that's f of x equals x squared. Here, I shifted the vertex 5 units right, so my transformation would be g of x equals x minus 5 squared. So again, that shift in the way that your brain sees things. So the c value here is a +5. Again, you've got to kind of keep everything straight in your head, and that's a right shift. You can also use the graphing function on your calculator, and that'll kind of help you keep the numbers straight. So here I've got a function written in vertex form, and it says shift it 2 units to the right. So what I would do for x minus 4, if I'm shifting it 2 units to the right, so here's right, and if I shifted it 5 units to the right, I subtracted 5. So here I'm going to subtract a 2. I'm shifting it 2 units to the right. And everything else stays the same. And then I've got to kind of simplify this thing down. So I've got 4x, -4 minus 2 is a -6 squared minus 1. So now I have to break this down, okay? So x minus 6, x minus 6. That is my first step, okay? So I'm going to have a 4 here. X times x is x squared. X times a -6 is -6x. -6x minus 6x is -6x. And then -6 times -6 is a +36. And there's still this -1 at the end. So all I did was I took this one piece and I broke it down to get this. It's still in parentheses. So I can simplify this even further. So I can do 4 times x squared minus 12x, that's combining like terms here, plus 36, and then minus 1. Now I can distribute. So I'm going to distribute this 4 across everything in parentheses. So 4 times x squared is 4x squared. 4 times -12x is -48x. 4 times 36 is a +144. And then I still have the -1 at the end. So my last and final step is to combine like terms. Let's write that with a g of x. G of x equals 4x squared minus 48x. 144 minus 1 is 143. Okay, so I'm breaking it back down to standard form. So now I have this one. It says shift 4 units to the left. So the first thing I have to do here is I have to put it in vertex form. So I have to multiply these two pieces together before I can do anything else. So x times x is x squared. X times 3 is 3x. 1 times x is x. 1 times 3 is a +3. If I combine like terms here, I get a 4x. I'm trying to save space here, guys. Now I can distribute this 2 out, okay, across everything. So -2 times x squared is -2x squared. -2 times 4x is -8x. -2 times 3 is a -6. All right, so now I have to write this in vertex form. I'm going to go ahead and just give you the vertex here to save time on this video, but use the previous notes if you need help finding the vertex. So the vertex here is -2, 2, and you can find this by graphing as well. So if I want to write this in vertex form, f of x equals, all right, the a value is -2, x minus the x value of the vertex, so if it's a -2, that's +2 squared, and then plus the 2 at the end, okay? So now, I haven't even performed the shift yet, okay? So to perform this shift, 4 units to the left, 4 units to the left, I've got to add a 4. So I'm going to do -2 x plus 2 plus 4 squared plus 2. And now I have to break this entire thing down again, okay? All right, so this turns into -2 x plus 6 squared plus 2. I combined my like terms here. Break down this part, the x plus 6. I'm just going to do it really quick again to save time for you. X plus 6, remember, x plus 6 times x plus 6. We'll simplify down to x squared plus 12x plus 36, but I still have this plus 2 at the end. Okay, so if I distribute this -2, I've got -2x squared minus 24x. -2 times 36 is a -72, and then still adding that 2 on the end. Finally, -2x squared minus 24x, combine like terms, -72 plus 2 is -70. So the left and right shifts are the most labor intensive. Vertical shifts are not as bad. Okay, there are a lot of steps. Okay, these are going to take you some time. These are going to take you some scratch paper. Take your time, go slow, and go a piece at a time. Don't overthink it. All right, so to move this up and down, we're going to add something to the end of the function. So not inside the parentheses. We're not adding anything to the x. We're adding it to the end. We're tacking it on to the end of the function. So this shifts the graph of the parent function up or down. If d equals 0, there's no vertical shift. If d is less than 0, it's going to shift the graph down. And if d is greater than 0, it's going to shift the graph up. This is going to affect the y-intercept of the parent function. All right, so my parent function here, again, is x squared, so it's that one that's lined up nice and pretty. Here, I shifted it up 2 units. Okay, so g of x, my transformation is going to equal x squared, and then I just add the 2 to the end. So this one, the signs don't flip-flop around like they do with the others. So the d value equals a +2, and that's an upshift. On this one, here's my parent function, dead center. F of x equals x squared. So this time I went down 2 units. So my transformation is going to be g of x equals x squared. If I go down, I'm subtracting 2. So my d value is a -2. And so that is a downshift. So a lot more simpler, a lot more basic to go up and down. All right, write the translated function, shift it to 10 units up. So all I have to do here is take the original function and add 10 to the end. That is it. Okay? No complex working through the vertex and all that. It still does need to be in standard form, and you do need to simplify like terms. And so 7 plus 10 is 17. Way easier, right? This one, I'm going to take this function and shift it 8 units down, so I just do the exact same thing. Take the original function and subtract 8 from it. And then simplify it down. G of x equals 5x squared plus 6x, -11 minus 8. It's -19 minus 19.